This is a session 3 of our fusion expression series, and that is how to implement trigonometry in your fusion expression. So before we implement trigonometry, I'm going to show you a brief presentation of trigonometry, so you can just familiar with that trigonometric functions, and I'm show very basic function and some idea regarding trigonometry. I'm not going very depth in that particular portion, but the necessary portion I have to show you. So let's start with presentation. So trigonometry. So what is trigonometry actually? So trigonometry is branch of mathematics that studies triangle and relationship between their sides and the angle between these sides. So where this trigonometry words come from? So this is Greek word, that is tri, that means 3, gon and side, and metron means measurement. So how these trigonometry words come? Okay, so this is just a simple explanation of the word trigonometry. So what is trigonometry? So for that we always study a right triangle where my C is my right angle, and if I consider A as my measurement angle, so the BC is opposite side of A, AC is adjacent side, and AB is your hypotenuse side. So trigonometric functions, so sine A is opposite side of A and divide by hypotenuse, so that is BC upon AB, and cos A is your adjacent side upon hypotenuse, that is AC upon AB, and tan A is equal to opposite side upon adjacent side. Okay, so there are more functions, but we are not we do not need that functions like cosec, cot and all this stuff. Okay, so whatever we need, I just show you those functions. So this is the basic idea of the ratio of your triangle. So now angle measurement, this is very important portion, because see, normally when we measure our angle we prefer degree, because we familiar with this device in our childhood, that we measure our angle in degree format. So like this 90 degree, this is 60 degree, this 120 degree and all these things. Okay, so we measure and we prefer these things, but there is one more measurement, and that is radian format, and this is very important when you deal with expressions. So see, what is radian? An arc of a circle with the same length as the radius of that circle subtend an angle of 1 radian. So like this is my radius, and this is same length of arc of this radius. So this angle is called 1 radian. So in our half circle there is basically 3.14 approximately radian. So what we call is pi. So there are 2 pi radians in a circle. Okay, so pi, everybody know life of pi, and the value of that, the pi is equal to 3.14 blah 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 and so on. So trigonometry circle, this is very important portion of trigonometry. The trigonometry functions sine and cosine are defined in terms of coordinates of point lying on the unit circle x square plus y square is equal to 1 square, and that is 1 square is equal to. So let's see the unit circle. So this is my unit circle, okay, where my origin is 0 0, this is 1 0 0 1, minus 1 0 and 0 1, and this is 0 degree, this is 90, 180, 270, 360. If I consider this as pi, so this is 0, this is pi by 2, this is pi, this is 3 pi by 2, and this is 2 pi. Okay, so simply the xy of any point on this arc is, because see, this is my theta, so if I consider cos theta is equal to x upon 1, so x is equal to cos theta, and y, for y, sin theta is equal to y upon 1, so y is equal to sin theta. So on that arc, the xy and the relation of that particular theta is cos theta and sin theta. So this is some basic idea. For example, angle in degree 0, 90, 180, 270, so 0, so cos is 1 here, in 90 degree cos, that is your x, is 0, minus 1, 0, and again 1. Okay, so same way for sine, that is your y, so 0 on 90 degree, 1 on 0 on 0 degree, 1 on 90 degree, again 0 on 180 degree, minus 1 on 270 degree. So this is some basic. So normally what I'm showing you, that the value of cos and sine is lies between minus 1 to 1. Okay, there is also a very important portion, that is inverse trigonometric function. So they are used to obtain an angle from any of the angle trigonometric ratio. So for example, see here, for example, in a right triangle I have two sides, for example opposite side and hypotenuse side, and I want to find the angle. So basically sin A is equal to BC, that is opposite side upon hypotenuse. So A is equal to sin invert BC upon AB. This is also called arc sine BC upon AB. So through that, if we have any two sides, we can find the value of angle. So now let's move into fusion, and I show you how to implement this function, as well as I show you some syntax for that trigonometrical function. So here I create one pendulum. Before applying any pendulum animation, I'll show you how to implement trigonometric function on any attribute or any property. For example, here I have Z, so I can rotate these things over here. So now see, there is very important portion. I just right click here, I add expression, so I can write here any expression. Here I have one PDF file where I can see some general mathematical function, how the syntax for that particular function. So for example, here I use any trigonometric function like cos or sine. So here the syntax is mat.cos and any value. So for example, here I write mat.sine, and here I write 0. Okay, that is mat.sine and your angle is 0. So it's give me value 0. This is obvious, because as you see here on 0 degree the value of sine is 0. Now we apply 90 degree. So here I write 90. but the value is something like 0.89, while here you can see the value should be 1. So what happened over here? So now see, this is very important portion when you apply any trigonometry function. When you put some value over here, this should be in radian form, not in degree form. Okay, so for example, you should put value in this format, so you get this value. So for example, here I write pi by 2, and for that, if I want to apply pi, so there is syntax for that, that is mat.pi. I just write mat.pi divide by 2, and that is pi by 2, and now you see you get value 1. So this is very important, that when you want proper value on trigonometry function, you should apply angle in radian form. Okay, so now let's move to our first example for trigonometry, and that is pendulum. And here you see the animation of pendulum. I just apply basic animation through keyframes, and if you see the graph of this particular pendulum, so it's look like this. Okay, so here maximum, minimum and all these things, so the value should be like this. So this is your angle and this is like that. So this curve is look like cosine curve. Okay, but the problem is that cosines give you the value between 1 to -1, and here the amplitude is between 30 to -30. So this is very simple example, that if you apply cos and multiply this thing with any amplitude value, so you get a proper range that is between -30 to 30. Okay, so our example, I'm showing you some more things. So this is my pendulum. I create this pendulum in Maya, and I just put the anchor point, the pivot point on top of this arm. Now see, I just minimize these things. So now here I create some controllers, so we can control our speed, amplitude very easily. So for that, here on any attribute editor or in tools, I just right click over here, I go to script, and here I have user control. So, and where you put that control, for example page, so this is my control, this is my 3D, this is my common script, this is comment and all these things over here. You can create your own tab using that, but I am put these things in that 3D. Here I put the name of that particular controller, so I put this as frequency and I click OK. So now see, here you get one more attribute, that is frequency. Now I again right click over here, go to script, user control, and again I go to page 3D, and here I name it as speed, and here I put by default value 0.1 and click OK. So here I got speed. Again I create one more attribute, and that is your amplitude, again on page 3D. So here I have these things. Now see, I want these things animate throughout my time. So here I just add one expression and here I write time, because the base thing that change over time is time, and I multiply this thing with this speed. Okay, so here I set my frequency through that both these things. This is my amplitude, for example I put that thing 30. Now I go to set rotation, I add expression. Here I write mat dot cos in bracket this frequency and multiply, because this give you value between -1 to 1. If you give any value, it's always lies between -1 to 1. So I multiply these things with this amplitude. Okay, so now you see you get a good animation. If I increase my speed like 0.15, so now you see it increased my value. If I set amplitude to 60 degree, for example, now I decrease my speed 0.05. So through this trigonometry we can create good kind of animation, and through this controller we can easily control the things. Okay, now let's move in to very interesting example, and that is your shaft and piston system. Shaft and piston animation. So for that, here I already create this piston and shaft thing using Maya. Now see here the very important portion. Right now I am put all these things on my 0 coordinate system, so we can easily do some animation over here, as well as I put some proper value. For example, here x scale, y scale is 6.03. So I measure these things, and the measurement is like this. So that this scale is actually the distance from this center to this center, not full on, because I want this radius for animation purpose. Same as for piston rod. Here the x length 14 point something is the distance between this to this. Okay, I am showing how I set this value in Maya in some another tutorial, and for piston I am not doing so much because there is only movement. I want basically this radius, and the length of this red rod is very important. So go to perspective again, I have these things. Now here we consider this wheel as our main animation. So here I just reduce these things and I just apply animation over here. That is maybe 360 degree. That is full rotation like this. Now I want my piston that moves around these things. Okay, so for that we already see one basic concept, and that is this. Okay, so we have to move our rod on this arc of that wheel. Okay, so simple things, we have radius, we have angle. So using trigonometry function, the x of this rod is r into cos theta and y is r into sin theta. So first of all, I have to create two control, and that is your theta and your radius. So here on wheel I create some controllers, and for that I go to wheel script user control. First I create wheel radius, and I'm here using my user control. Okay, so I get one new tab. Okay, so here I create controller for this piston system. So wheel secondary, I want the angle of this wheel but in radian format. So for that, go to expression, again I create one control and I write wheel angle. Okay, again over here. Now here I add expression and I just put these things. I go to there and I pick any of this value, so that is my radius. So here I got this radius. Again I add expression, I click over here, I go to this and I pick this rotation. And now I have to, because this rotation, the value over here is in degree format, and I want this rotation, this angle in radian format. So here we have one function, that is mat.rad, that returns the value of and convert from degree to radian. So here I just write mat.rad and I put that thing in bracket. So here I got radian form. Okay, now I select this thing, I go to X, I just put expression and I select these things also, pick these things, go over here, this wheel radius, and for X, as you see, that is cos theta. So multiply mat dot cos in bracket this angle. Now I just copy these things, Control C, I go to Y, I add expression and I just paste these things and just I change is here sine. Now you see your piston, your rod move according to this. Okay, just what we have to apply is just change my Z over here. Like this. Okay, so my one task is completed. Now the another task is to move my piston, move my rod in like this way. Okay, so for that I have to find the maximum angle of my rod. So maximum angle is simple, sine inverse R upon L, and the moment of these things is sine the wheel theta into maximum theta. Okay, so first of all I have to find the maximum angle of my rod. So for that, again create one controller, user control, here rod max angle, okay. So for that we need the radius as well as length of my rod. So for that again I create one controller and I write rod length, and here I call these things using expression. And that is this X scale of my piston rod. Okay, and here I have to find maximum angle. So for that, sine invert R upon L. So for invert function I have to write this sentence, mat dot a sine. So here mat dot a sine R upon L. So radius is this, divide by this, and I want this value in degree form. So here I just write mat dot degree. So basically this answer, that sine inverse, give you in radian format. So I have to convert that thing into degree because our attribute is based on degree measurement. So here I got that maximum angle. So now I just apply these things like on this Z rotation. So I just write add expression, and here as you see I have to assign this thing, sine the angle of this wheel into maximum theta. So here mat dot sine bracket, so angle of this wheel in radian form into this maximum angle. So it's give you like this, but here I have to change something, that is multiply with -1, because the systems work sometimes in negative space and all this thing. So here as you see now, now you see thing move very properly. Now it's turn to move our piston with this. So for that, the maths behind these things is very simple. We have R, we have L, we have this changing shaft theta, we have wheel theta. So that is this A plus B. So A is equal to R into cos wheel theta, and B is equal to L, that is rod length into cos shaft theta. So that is A plus B, basically because our coordinates move on 0 0, so we have to just find this and just plus these things. So here again I create this both thing, and that is script user control, and for example I write A and LAN. Okay, I create one more control, and that is P LAN. Okay, so for A, what we need? Radius of this expression. I just need radius of wheel into mat dot cos and this wheel angle. And for B expression, we need length of this rod into mat dot cos into the shaft angle. So for that I create one more control, so we can easily do things. So rod angle. So here I call these things add expression, and I call this Z rotation, and I have to convert these things into radian form, and now I call these things over here. Okay, now the simple thing is I go to piston, I select my wheel also, and piston, to X expression, and here A length plus B length. Okay, I have to also set something, and that is your Z. So I add expression, go to piston rod, and I set Z offset. So now you see you get a proper piston animation using trigonometry function. See, these things is little difficult, but if you do some practice, you implement some examples, you study trigonometry in a little depth, you get very good result. Okay, now you have to just modify your rotation, that's it. So if you change your rotation, it automatically give you the other things properly. Okay, so hope you like this tutorial. We'll see session 4 very soon.